Perhaps the most exciting and contentious application of AI comes in the form of generative AI, those amazing tools that generate text and images and now music and video. Now, the output from these can often be indistinguishable from content created by humans. And of course, this is for a good reason. You see, everything that an AI generates is based on examples that it has been trained on. Now, everything that an AI is trained on is encoded in what we call the model. So all that data is said to be latent in the model, which is just AI speak for it's hiding out inside the model, ready to be called on as needed. Now, videos are a visual medium, so let's illustrate this with an image-based generative AI. And if you used one, you'll know that you simply provide the tool with a prompt, which is the textual information that you needed to know about what kind of image that you want. Let's ask for a realistic photograph of famous Bollywood actor Anil Kapoor as he appeared in 1985, but he is surfing with a cat somewhere in Canada. I really have no idea why I picked this subject. Okay, let's see what we got. Well, they're not bad, I suppose, but how does this work? The model used for this was trained on a huge number of source images, each of which were tagged with a description of what's found in the image. This one's a chess piece, the king. It's a white piece. It's on a chessboard, whatever. Hey, this one is Anil Kapoor. The year is 1985. He is in a film called Marijang. I don't know how to pronounce that. I think I got it right. Of course, the model would be exposed to hundreds or even thousands of images of these types of items. Different chess pieces, Anil Kapoor in different movies from different times, different angles, different lighting. The algorithm to generate an image from the model is actually quite interesting. It began as a tool to clean up noisy or dirty images. The creators of the tool realized that even a very degraded image could be restored more easily if the restorer knew what the subject was. One day, someone had the bright idea to give the new tool an image of nothing but random noise, but to tell it what the image was supposed to be. And it worked. So these generators start with a random field of noise and are given a subject to work with, to match. The model contains lots of latent data featuring the subject, so it cleans up the image and compares it to what it has stored about the subject. And it continues to do this until the image is suitably clear. We can actually see this if I stop the tool prematurely. You see the field of noise here? We can just see something in there that's starting to look like an egg. Other generative AI tools work in the same way. They may not be trained on visual data, but they reference their stored information to form their output. But this is where the trouble starts. There is significant debate as to whether models trained on specific inputs can actually output something new, or if the output is simply derivative of this source material. Now, what do I mean by this? Well, not long ago, the AI image generator DALL-E was found to have been trained on images from stock photo sites. Now, how did the researcher who found this out know? Well, they were able to prompt DALL-E in such a way that the original watermarks from the training data that's applied to the stock images were clearly visible in the output. So, who owns the generated output if it's almost identical to the source it was trained on? This problem extends to all generative AI trained on material that's not in the public domain, and this is why some companies are quite uncomfortable using them. What if the code you generate from Copilot, which was trained on both open and proprietary code stored in GitHub, which Microsoft owns and operates, as well as other online sources, of course. And what if it's found to contain large chunks of someone else's code? This actually happened back in 2019, and quite quite a furor erupted. Here's another challenge. Let's ask our image generator for a highly realistic and detailed photograph of Ryan Reynolds shaking hands with Marilyn Monroe. All right, let's take a look at the output. All right, first of all, these aren't that good, right? These don't look very realistic. Is that even the right number of fingers? Well, we know what these people look like, so we can tell if it generates what we want. And of course, Ryan Reynolds was born 14 years after Marilyn Monroe passed away, so we know these images aren't real. Okay, let's change the prompt to something that is pretty realistic. How about a photo of Grace Hopper posing with Ada Lovelace? All right. Hey, these look pretty realistic. And if I gave you these, you'd probably believe that these two people knew each other, got their picture taken together. I don't know if you know, but Ada Lovelace was indeed a famous mathematician, and Grace Hopper was a major computer pioneer who was said to have coined the term computer bug. Well, if I give you these pictures, they'd all make sense. We can use these pictures, right? But what if I told you that these women lived in different centuries? I mean, Ada Lovelace was active in the 1800s, and Grace Hopper did her work in the middle of the 20th century. If we just trusted the output of the generative AI, we would come to the wrong conclusion. You see, generative AI speaks or draws very confidently, even when it's wrong. Write an article about the new Linux implementation on the Commodore 64 computer. Include citations and references. Hey, this looks good, right? Too bad it's all fiction. None of this is true. The citations are bad links. This is crazy. You're probably familiar with the limitations of using generative AI for coding purposes. And the same thing goes for anything else that you ask it to do. You need to validate what it outputs. You need to fix its errors, large and small. If you use it to help with, say, coursework, you're still going to have a lot of edits and checks and corrections to do. And this, folks, is why I always say AI is a great place to start from, but a lousy place to end up.